our session. We're really fast today. There's a very few questions. Okay. Okay. Thank you for that. Okay. So yeah, let's just eat after the session and then I'll just chat with you guys. Right? Software engineering practices. So the whole thing that we have been discussing is all about values. It's all about working in iterations, day to day. You can't be agile if your actual code is not flexible. There's no point. If the way you design your code, the way you code, the way you program is not prone to change, drop the whole thing. It's very important that you have solid software engineering practices, solid engineering foundation. I will just do a sweeping thing here because they warrant their own trainings altogether, like month-long trainings actually. So the simplest is use a source control management system. Don't use saving multiple files. This is July 15 file. This is July 16. I don't know if someone else is still doing that, but very simple. I wrote this simple thing, I wrote there because it's tightly coupled with this one. Continuous integration. What is continuous integration? For developers. What SCM do you use? You use CBS, SVN, Visual Source Safe, SVN, even for RPG, is it? Manual. Okay, okay. But you still have that source control management, right? So, now what is continuous integration? That's pretty much tied to that. What is continuous integration? Bring them together quickly. Yeah, so, you are continuously integrating your source code, especially if it's just one source control manager. If I code and then make a lot of changes and then wait around until it's done and it took me 5 days, and then I check it in, all the other people who are also operating with the same code might get angry at you for destroying their other week-long work. Continuous integration is a practice wherein you continuously integrate changes that you are doing. Continuously. You don't finish the whole thing and then check it in. You chop it into small bits that is safe enough to check in. Now this takes a lot of practice. This takes a lot of discipline. And I actually have 2 days training for just this. Okay, continuous integration. Some people say it's the server, continuous integration server. If you know Jenkins or Hudson and Chief Control and all these things, they just facilitate continuous integration, but they are not continuous integration. They are continuous integration servers that make sure that all the stuff you check in are not garbage, are not breaking the codes. But you can do continuous integration without these tools. Is this applicable to RPG? Can you do test cases? Okay, like a unit test, like a small unit test.
Well, you can obviously unit test the program, but whether I guess you could, if you really want to be efficient in the way you write, you could just write the insert, and the test case for that, and so on.
Okay, okay.
If you could do it, I'm not sure it makes sense.
Okay.
Yeah,
because in Java and in C, we have JUnit and I forgot the name for
there is an RUnit.
RUnit.
Yeah.
Okay.
So we're looking at that at the moment. From JUnit.
Yeah. It's gonna be very different because for object-oriented programming languages, the smallest unit is an object, right? For RPG, it's a function or a procedure or.
No, it's pretty much one little program.
Oh, one.
Yeah, I mean, you can break them down, obviously, into smaller chunks. But the
Yeah.
Isn't that efficient?
Yeah.
I mean, you're talking about programs of 20,000 lines.
Yeah. Doing one thing.
Yeah.
Okay. Yeah.
Concepts, it mimics the object-oriented program. Because we have a speed handler for speed, we have
Okay.
a big
But they're taking over and reinitializing programs.
Okay. Okay. So you need to initialize a big thing before you could actually test. Okay. Because unit testing should be the smallest unit. For a functional programming language, it's a function. We're just testing one small function. For object-oriented languages, methods of the object, or things like that.
Well, you can do it, but I mean, certainly Lindas was really great in the system going so in the 1970s, where you had that.
It's a legacy.
Yeah, you wrote a big program, so you've got a lot of legacy code.
Yeah.
The reality is you can't just change one bit.
Yeah. But the small bits that you put in, maybe you could start introducing test cases. Is that something possible?
Yeah, I would say to an extent, yes, it is possible. But whether it's efficient to write it that way, because you go in and tweak the program, and those fields are on the party program. So you're generally better off with a big program doing
And then
it.
test it.
Unit test the whole thing.
Yeah. Because that's no longer unit testing, that will be functional testing already, or integration testing, some sort
No,
of
it's still
thing.
within one program. It's not even link testing, exactly.
Okay, okay. So there's still that bigger test.
Yeah, I mean, so there's a bit of an equation and logic there. I mean, we've got 13 million marks. Across a number of programs. And it's hard now to re-engineer that sort of challenge.
Okay. I'll be discussing clean code later on. Let's see if that's something that might be applicable. Because first of all, test-driven development is actually writing tests before actually developing. Why does that make sense? So that you ensure that you have unit tests for everything.
Well, basically make sure you're thinking about what you want to test. So you basically it's your assignment.
Yeah.
It's your exit.
Yep. So 7 habits of highly effective people again. That's, I think, number 2 habit. That's beginning with the end in mind. You know when to stop. You know when you've accomplished the task. You put your contract first. Your test is your contract that, hey, it's done. I won't go out of scope. There's no scope creep because that's the minimum that I need to do. And it's done. And this is at the very finest level, which is the objects for object-oriented programming languages. Acceptance test-driven development is different. Acceptance test-driven development is testing a bigger chunk of the system wherein the business analyst is already involved. Unit tests or doing TDD is purely development work. It's for developers, for their benefit of understanding it. Acceptance test-driven development, on the other hand, is when the whole team is involved. The BA writes the test cases. They could write it in text format or whatever format. We've got tools to do that. And then the developers grab that and let's see if that works. Okay. So again, I'm just brushing through this. Some things that you might want to look into that might be applicable to what you're doing right now. Now, I was talking about clean code. Now, clean code is about being a Boy Scout or a Girl Scout. When you come into camp, you leave camp cleaner than when you got there. So, for example, for a monolithic system, it's really hard to put test cases on everything. Or in a Java project, you don't really go in and dedicate 1 month adding test cases or cleaning it up, refactoring it, and all these things. Clean code means whenever you come across something that isn't really good to look at, okay, you clean it up bit by bit. So every time you pass through something, when you're working on a task, you interact with a function or a class, and you see something wrong with it, clean it up a bit. Not too much that it takes the whole time, but strike a good balance that every time you pass by something, you do a good deed. Yeah, there's a full book about clean code and how to approach that. I don't know if it's somewhere there.
That can increase your overhead.
Yes, it will increase the overhead, but it's accounted for in your velocity. If you're consistently doing it that way, then when you start projecting, that's already there.
If I mean, I think it's also you found something, so now we're going to do the test case for it. Because you've got to test that change.
Yeah, yeah.
So you're actually producing new work that you didn't know about in the first place. So
Yeah.
if you started off writing a test at the beginning, you've now blown that, you're now going to have to do test case build during.
Yeah, but we didn't estimate in hours. Because if I estimated in hours, and that actually took me 2 more hours, and then I totally skewed the original estimate. But I estimated in story points, which is variable. Variable in terms of time. If the team is consistently doing that, that hey, we're actually creating new test cases, probably around 2 to 4 roughly every time we work on a task, and then that's consistently happening. That's captured with the whole velocity concept. That's my problem with really estimating in hours, is that I only estimated for this, and that's the only thing I'll do. Unless you creep it in, and I don't know how you would be able to pull it off. Unless you work faster. So, continuous attention to technical excellence. Because what happens to software projects? So let's say this is the defect axis, and this is the lines of code. Technical debt is, technical debt is that, like, you are incurring defects in order for you to go fast, right? You want to go fast, so it's okay to have technical debt for now. But the problem is, interest is like that of a credit card interest. It's the worst kind of 5-6 in Filipino. It's the worst form of loan. The interest will actually mount up to the point where you won't actually move forward anymore, and then you drop that, you do a rewrite, and then you do the same thing. With people doing clean code, yes, you do incur technical debt, but up to only an extent where you don't reach that spike. Just enough so that you move forward, and then you start cleaning it again. Yes, it will slow us down. I mean, yes, we will have 20 story points on the next iteration, but when we start paying our debts, it becomes 5, becomes 4, becomes 5. You start paying it with interest. So that's clean code. Entropy. Pretty much that's entropy, right? Solid principles, I think this is only applicable for all object-oriented programming languages. There's the book there, Agile Software Development by Bob Martin. He outlined the solid principles. Solid principles is an acronym of single responsibility principle, open-close principle, list-off substitution principle, interface segregation principle, and dependency inversion principle. So all these principles, if you do them, it makes your code easier to change, more flexibility. Again, that's a good 1-week training for solid principles. And pair programming. Pair programming is the most misunderstood practice. It's about 2 people working together in one workstation. Managers don't understand what that is. Yeah, that's part of extreme programming. Pair programming is working at the same, with the same machine, with another person. Why is it advocated? What's the benefit of doing that?
It's sort of a cohesion where two heads are better.
Two heads are better than none. Yeah, two heads are better than one. Yep. It's not really about coaching. You're missing the value of pair programming if it's about mentoring and coaching, because you route the productivity of a Yep. It's bouncing ideas. It's quick feedback when you get stuck, and you get very productive because your pair mate or your programming mate is not opening Facebook. Why would I open Facebook with something there? It's very intense. Whenever I do pair programming, I really enjoy it because I get challenged. You talk first, how do we attack this problem, and you do a design discussion with your pair mate, programming mate, and then someone becomes the driver, one is the navigator. The problem could be very complex, you chop it down to small bits, the driver will be immersed with the task at hand, and he might get lost with regard to the big picture. That's why you have a navigator. And then the navigator looks at what he's doing and looking at the big picture, where we're at, and then when he gets stuck, let me drive now. And then you go.
That's quite a lot. That's one of the things that we benefited from the most was finding typos and stuff. Because this isn't working. You spelled that wrong.
Yeah, a second pair of eyes.
That's a fair right.
Yeah.
It just saves you, because you read what you expect to say.
Mm-hmm.
You know,
Yeah.
the person coming in just looks from immediately.
Yeah, there's a disconnect with his fingers and the eyes, right? So it's very intense. We have to take hourly breaks because it's very intense when I do pair programming. And just make sure you brush your teeth, because you put deodorant on or something. It's very intense. It's very tiring. At the end of the day, even after 6 hours, I'm very exhausted, but it's very fulfilling. That's something that you may want to try out. Now, this won't come without respect. You have to respect who you're pairing with. Because if you belittle his tech skills and you override everything, there's no benefit in it. Just work on your own. Respect, and again, deodorant. And respect for space. So, different cultures, like, I don't know if it's India who's better working in close proximity. Some countries, they want some space, so.
Yeah, the UK.
UK,
much
yeah.
bigger personal space.
You want some big, yeah. So you're pairing here. Hey, so what's next? No, I'm just kidding.
You also used to keep talking about that.
Yeah. Yeah. So, respect. It's all about respect. It's all about putting something to the table and challenging each one. And again, take a lot of breaks because it's very intense. Or is it just me? But yeah, in most cases, yes, it's very intense. Pair programming. Whoa.